Hey guys, I just wanted to quickly do a video um, about this vaccine that is coming out. So, um, there were a couple of companies that were like leading companies, as one of them being the AstraZeneca, and of course Pfizer and the Bionic. Of course, Bionic. The issue with Bionic, well, it's not an issue per se, but Bionic requires extreme temperature, extreme cold temperature to store the vaccine so that it can be delivered. But according to the sample, um, or when they did the analysis of efficacy of the vaccine, what they found out that the Bionic and the Pfizer was 90% have 90% efficacy, which is good. But earlier on, as AstraZeneca, that is co-joined with the Oxford, to produce the vaccine, actually reported 95% efficacy on it. But we just which was good, and they require normal temperature to store it. So that was really good. Sorry guys if you can't really see my face. It's just my camera is not working great today. So, but anyway, um, so back to this. So it's not a problem, but right now after they came up with the 95% efficacy because they had a small sample size. So statistically, this is where there is a statistical error, I think, and the error is based on the sample size, because I think the sample size that they took did not exactly represent the entire population, and based on the small and they didn't, this is statistically this is a problem. So there's two things about statistic. One, you have to have big enough sample size to be able to at least to be able to test your hypothesis, which in this case was that AstraZeneca vaccine would be effective 95% of the time. So that's that was the hypothesis that was tested, and that should be with a 95% 95% certainty that it will work 95% of the time, which is the efficacy of it. So you only have a 5% margin of error. But this is the thing with statistics. For you to have a good result statistically, you have to have two things. One, you have to have a sample size that represents the entire population, and you have to have large enough sample size. Very important. You have those two things. So I think what happened with AstraZeneca, it's not. I know for a fact this is what happened with AstraZeneca. One, clearly their sample size based on what was reported was small, and I would not be surprised to find out that the sample size also did not represent the entire population. So now, after they tested it on a bigger sample size, yeah, right here it says that I don't know if you guys can read it. I don't want to highlight it, but it's right here. It says that the FDA found that um under a large trial whereby 20%. This is what I was talking about. The sample size did not represent the entire population. You have 20%. I guess they had 20% less older people. So this one says a large trial in which 20% are older people, and there is a greater ethnic representation is being conducted in the U.S. you know so, and because of this disparity, statistically disparity, I guess, the FDA is probably unlikely to approve this vaccine as quickly. But apparently in the UK and Europe, I think they're moving forward to, I mean, they just need something who blame them. But anyway, the key, I just want to pull out the key of the key point from this the Guardian newspaper, or the Guardian website. And right now, AstraZeneca is actually reporting 65% efficacy. That is, if you were to go to school, a 70% would barely be a C. A 65% is a failure. Yeah. And from a statistical standpoint, this is not good. For you to be absolutely certain that something will work and it will work all the time, you have to have 95% accuracy. Your hypothesis has to test 95% of the time. I don't want to get into so many technical thing right here, but this is a norm. A population is represented by a normal distribution. And a normal distribution, you have a 5% error if you're doing a one end test or double end, two end test. In a two end test, you have 2.5 margin of error. They are not even within 95%. For them to be, for this to be right, they have to have 35% margin of error. Do you know what it means to have 35% margin of error? That means that it's a, you might as well, this is almost like it's a 50-50 shot. Yeah. This vaccine is almost a 50-50 shot that it will protect you. I don't want to, I don't want AstraZeneca, or I don't want to. I mean, they did a good job. They put in the time and stuff, but it just does not work for the entire population the way it's supposed to work. I mean, walking around with a 70% efficacy on something as deadly as the COVID-19, I don't think it's good. I don't. I think maybe at this point Pfizer and Bionic probably will be the best up. Yeah, Bionic will be probably the best shot. Then again, let me be clear though. Let me just say one thing. It is better than nothing. You feel me? And because I mean, you might as well just walk around wearing masks. Masks. I don't know what the efficacy rate with masks is, but I guess if you take a AstraZeneca that has 65% possibility or even 70% efficacy rate, and you combine it with a mask, I guess the world would be okay. We just walk around with a mask with and a 65% vaccine efficacy. I think what we need to do, we got work to do. And that's another thing. I hope this is not the same case with Pfizer and Bionic. I hope they actually had a sample size that represented the entire population and a sample size that was large enough. So it is the statistic that the population, I don't know if the public have access to this information. I would hope that it's a public record. They probably won't do it because of, IP and stuff like that. But anyway, so I just wanted to quickly, make my own comments about this, from a statistic standpoint. Yeah. So okay, let me just quickly touch on this before I end this video. If you guys see where I just highlighted right now, they say both the Pfizer and Bionic and the Moderna vaccine have reported 95% efficacy in their trial. See, there's let me point out something. A 95%, is the minimum you can get. Statistically, for your hypothesis to be considered true, in this case, the hypothesis that this vaccine would work. There is 95% chance that this vaccine will work, and there's a 5% chance that it doesn't work. That sounds great, right? But there's a problem. Statistically, 95% is the minimum you can get. The margin of error is exactly 5%. You can't have any margin of error larger than that. If you have margin of error larger than 5%, then it's very likely that your vaccine is a matter of chance. And when I say it's a matter of chance, that some people will take it and it will work for them. Some people will take it, it won't work for them. That's what it is. For you to make sure that your hypothesis is not a matter of chance, who gets lucky, you have to have 95% plus, 95% upward. So when Pfizer and Biotech report 95% on this vaccine, I don't know whether they're being nice Because statistically, they're right. It's true. 95% is that's it. That's the bare minimum. But is it truly 95%? Because a 95% is like, it's like when you get a 70, like you get a C in school, right? It's possible that you had a 75. It's possible you get a 78. It's possible you get a 79. All of this is still C. Even if it's C plus, it's still C, right? But when you get a 70, that's the minimum you can get for a C. 1 point below that, you in the D. You fell in that class, that course. So now that I put it in perspective, I hope you guys understand what I'm saying. 95%, if this dropped down to 94%, it's possible that some people will take this vaccine from Pfizer, Biotech, and Moderna, and it won't work for them. And some people will take it and it will work for them. I don't know if that's what we want. But then again, 95% is way better than 65, 75% reported by AstraZeneca. But anyway, I guess we just have to wait and see what the future holds at this point. Because these numbers doesn't look. I mean, as AstraZeneca said, they went to Brazil and tested it, and I think they came up with so many percent efficacy in Brazil. That's what they wanna go with. As if so many percent was even good. And right there, if you read it, they say the efficacy data is based on 11,636 volunteers across UK and Brazil. There were just 2,741 people in the subgroup who received a low first dose, half of whom received the vaccine and half received a placebo. But efficacy in the group was 90% compared with 62% among the rest. So at their base, they got 90%. At their base, on a selective group of people, and mixed with control group and experimental group, they're trying to throw so many numbers at this point. I'm even at a 90%. Statistically, at a 90%, you are below 5% margin of error. You are at least 10% margin of error at this point. So there's a 10% chance that you take this vaccine and it would not work. I don't want to make this so scary, but let me put it this way so that you guys can understand what I'm trying to say. If you were to go into a surgery or about to go into a surgery, and the surgeon tells you that 90% of the time this surgery will come out fine, you'll be all right. There's a 10% chance that you're not going to be all right. Let me ask you a question. Would you think twice about it? If there's any way you can avoid that surgery, would you not? You would. So you guys think about that. But all this company, AstraZeneca, Bionic, and Pfizer, and of course Moderna, I think they did great work. I think they did a fantastic job. But this numbers is not. This numbers is. It is what it is. It is what it is. And there's this thing that we're saying when it comes to numbers. There is lies, there is damn lies, and then there is statistics. Alright guys, that's all I need to say for now. And as this thing changes, I'll keep you guys updated. Appreciate you guys tuning into the channel. And if this is your first time, please subscribe so that we can produce more content like this, a variety of content. Look at my other videos. I have music videos, I have remix videos, I have technology videos, so I'm very versatile. So I do all kinds of videos. All right. Appreciate you guys. Thank you. Peace out.